Hi everybody, Patrick here from EngineeringShock.com, EscapeRoomElectronics.com, and PaintballProps.com. This is the Hallowe'ener assembly and test video. The Hallowe'ener is a motion sensor-based Halloween prank for trick-or-treaters, friends, family, etc. The Kickstarter campaign is linked below. Let me talk to you about the components and then we'll start assembling and testing. So this is the printed circuit board, 5mm power jack, 78 LO5 5-volt regulator, 8-pin dip socket, 8-pin microcontroller, 16-pin socket, 16-pin audio processor chip, 3 0.1 microfarad ceramic capacitors. They're labeled 104, they're all the same. 3 10 microfarad electrolytic capacitors, a single 3mm red LED, an audio jack right here, PIR motion sensor module, 2 470 ohm resistors, and 2 1 microfarad electrolytic capacitors. So first of all, we're going to solder in our 2 470 ohm resistors. Now if you can't see it, the 2 resistor slots are right here. They're labeled 470R, and resistors don't have a polarity, so you can solder them in directly. Make sure they're flush to the board and that your solder joints are strong and then there's no shorting between the 2 resistors. Once we're done soldering the resistors, we will do the ceramic capacitors. The ceramic capacitors do not have a polarity. Both leads are the same length, and so you don't have to worry about incorrectly placing the capacitors, as long as they go in the right slots, of course. So the first ceramic capacitor goes in the C3 slot right here, and the second and third ceramic capacitors go in the C7 and C13 slots. Right there, side by side. Now make sure that the solder joints are fine and that there are no shorting between the 2 middle leads. If you short those, you will have trouble. So make sure that your capacitor leads are properly soldered, no shorts, and that once you're done, you cut the leads cleanly from the bottom of the board. What I like to do is place them and bend the outer leads towards the edges of the board and leave the middle leads standing straight up, so that you have a better chance of not shorting when you solder. A fine tip soldering iron is required for this. Notice that the 10 microfarad electrolytic capacitors have a short lead and a long lead. Long lead is positive, short lead is negative. Very, very important for you to take that into consideration, because if you place them backwards, you power it up, some of them will likely blow up. So they are placed here, labeled 10U C2, C1 10U for 10 micro, and C8 10U right here. So here, here, and here. Now, you're not going to be able to see it in the video, but you'll see it up close. There's a tiny plus sign on all of the capacitors indicating where the long lead should be. In the case of C2, it is the top lead. The bottom lead, the bottom hole is negative, the top lead is positive. So long lead in the top, short lead in the bottom from this perspective. In the case of C1, long lead to the left, short lead to the right. In the case of C8, long lead to the left, short lead to the right. Look for those little plus signs. Plus equals long, and there is no negative indicator on the footprint, so just make sure that you place the long lead in the case of C2 top, C1 left, C8 left. So once you solder those into place, we'll do our 1 microfarad electrolytic capacitors. Our 2 1 microfarad electrolytic capacitors also have a long lead and a short lead, and they are placed in C12 and C9. Long lead to the left, there's a little plus sign on both of them, and short leads to the right. Make sure that you don't reverse these, or else your audio output will not work properly. Long leads to the left for both of them, short leads to the right. The audio connector has 5 pins on it, 1 in the front, 4 in the back, and they're placed in this little slot labeled AUD out, for audio out. So what you want to do is you want to line up the ground pin first, the front pin, and then slide back and make sure that all 4 of the back pins fit into the back holes. Now I've got a little bit of a trick for this. I'm going to try to get it on camera here for you. Okay, this might be hard to follow, but what I like to do is bend back the ground pin, the front pin, just a little bit. Bend it back just a tiny bit, and I like to line that hole up first. Again, I'm sorry if I can't really show this to you very well. And then I like to push back just a little bit, and the back pins should fit in place. Just be very gentle. You want to make sure that once you've put it in place that it's flush to the bottom of the board and that you can visibly see, even if only by a little bit, the pins protruding through the back of the board. From there, hold it in place with one finger and solder. Add a little bit of solder to the tip of your iron and just dab it on the ground pin, the front pin. That'll hold it in place. Then you can solder the back 4 pins and then resolder the ground pin. The regulator, which is noted on the footprint labeled as IC2, is right here. Now this is the 78L05. The front is flat and has writing on it. The back obviously is curved and it teeters. We can see that. So on the footprint, I'm hoping that this is clear. There's a flat side and a curved side of the footprint. So what you're going to want to do is make sure that the flat side of the front side, the flat side on the regulator faces left, and that the curved side faces back from a bird's eye view. So you'll have to line up all the holes, push it. It doesn't go flat down onto the board. It doesn't need to. Just push it down to about the height of the capacitors. I'll show an after picture. And just so you make sure that you get the orientation right. If you solder this backwards, your regulator won't work, and therefore the rest of your circuit will not work. This circuit, or rather this component, takes the input voltage of 9 volts and regulates it down to 5 volts to control the digital circuitry. The LED has a long lead and a short lead, much like the electrolytic capacitors, and it goes in the L1 slot right here. So what you want to do is, from this perspective, long lead in the left hole, short lead in the right. If you reverse this, your LED will not work, and you're not going to be able to see, you're not going to be able to calibrate the PIR sensor, because that LED acts as an indicator to show when motion is detected. The power jack has 3 pins rather, and it fits only one way from a topside view into the socket. When you place it into the footprint right here, you want to make sure that it's flat and that you don't overheat it when you're soldering the 3 holes. If you overheat it too much, you'll damage the inside and power won't get to the rest of the circuit. So take your time with it. You don't have to fill all 3 holes. The ones that are of most importance are this one and this one. This bottom one is of little consequence, but it keeps it in place. So solder it, take your time, let it cool off. If you think you're overheating it, just be slow. You're not at any large risk of damaging it unless you're really heating it up overkill. So what I like to do is dab a little solder here, then here, then here, then here, then here, then here, and it really doesn't take very long. So next we'll do the sockets. We'll place the chips, and lastly we'll solder our PIR sensor. You'll notice that the sockets on the left side have a little notch on them. It might be hard to see in the video, but you'll see it when you receive your kit. The footprints on the board have a notch facing the left. So from a bird's eye view, you want to make sure that you place the sockets with the notches facing the left, because that's going to be our indicator. Sorry, I don't want to get my hand in the way. That's going to be our indicator on how to orient our chips. So make sure that when you solder these, that they are flat to the board and that there are no shorts in between the pins. Any shorts will potentially damage your Hallowe'ener, or at the very least compromise functionality. So solder those 2 into place, take your time, and then we will solder our PIR sensor and give this a test. I'm hoping that you can see the little notches on the left hand sides of both of the microchips, the integrated circuits. So you have to make sure that from this perspective the notches are facing left when you socket them. Now there is a bit of a trick here, and you want to be very careful that you don't bend the leads when you're placing these. What I like to do, and again I'm not sure if I'm going to be able to do it well in front of the camera, is I like to place the bottom leads first. I'm sure that, yeah, I'm blocking the camera, I'm sorry. I like to line up the bottom leads. I'm just going to line them up, and then I'm going to move back. I've lined up the bottom leads, I can feel that they're all in their holes, and then I like to essentially massage the top leads into place, pulling back on it. Now once you're convinced that all 16 of the leads are lined up with the holes, you can gently push it down into place. Same goes for the 4-pin chip. You want to be very, very careful. Make sure that you're positive all of the leads are lined up before you push into the board. If you push them into the board improperly, and you'll know pretty quickly, you'll have to look at it from all angles to ensure that all leads are in the proper holes. If you've bent a lead, what you can do is gently remove it with a flathead screwdriver from the side, and then you'll have to take some needle nose pliers and reshape the leads so that they're straight again. So I'm going to place these, and then we're going to solder our PIR sensor and test. The PIR sensor has 3 leads to solder into the front and 2 variable resistors in the back. We're going to talk about those when we calibrate. So I'm going to line these up. And what I'm going to want to do is, once I've lined it up, you want to make sure that you solder it so it's flush, so that it stands straight up. Because if you have a little bit of leeway there, you want to make it, and if you have it bent in a certain way when you solder into place, it's not a big deal, but it's just not aesthetically as pleasing. So what I like to do, again, I'm going to try to. You can use the PIR sensor to hold itself in place. Dab a little bit of solder on the top lead. Make sure that once it's dabbed there, that everything is properly connected, and then you can look to ensure that it is fully straight, and then you can solder the rest of the leads. So I'm going to solder that into place. We're going to light this baby up, test it, and calibrate the PIR sensor. I find that the best way to calibrate the PIR sensor is to orient the variable resistors on the back of the PIR sensor this way. To the right, the indicator facing the bottom, the flat indicator facing the bottom, and the left, the indicator facing the upper right, as far upper right as it will go. You can gently change that with a small flathead or Phillips head screwdriver. You want to be very gentle. Now, if your LED always stays off when you power up or always stays on, you've got a problem. If it always stays on, you've likely got a calibration problem. Now, you can fiddle with those variable resistors as much as you'd like. You're not going to hurt the circuit. If the LED is always off, what you can do is you can try to troubleshoot. And here are some troubleshooting tips. Set your multimeter to measure DC voltage, and what you can do is, using the black probe the upper pin hole right here, labeled G for ground, and your red probe to the V plus pin to the left and the right, or rather top and bottom of the power jack. These 2 pads can be used to provide power through a 9-volt battery if you solder to the bottom of the board. And when you power it up, it should read 9 volts. Right now it's just reading residual power on the capacitors. As you can see, it's draining. That's nothing. If you are reading 9 volts there, what you can do is very gently place the red probe after you've powered on to the second pin of the small chip here, pin 1, 2, 3, 4, 5, 6, 7, 8. And you place the red probe on pin 2, not shorting to the other pins, and the black probe to pin 7, and it should read 5 volts. If it's not, you've likely got a short somewhere, or a damaged component. That's not likely to happen, but that is how you can troubleshoot. If you have any questions on that, you can please feel free to let me know. So let's power it up and make sure that we've got our PIR sensor calibrated properly. If all is well, I'll plug this in. The LED might turn on and off a couple times. I'm not plugging in the stereo connector just yet. I just want to give the PIR sensor a minute to adjust. When you power up a PIR sensor, it takes a second to adjust to its surroundings before it starts being accurate. So if the LED flickers on and off a couple times, no worries. I'm going to plug it in, and I'm just going to walk away and give it a few seconds to calibrate. And once it's calibrated, you can plug it into your stereo system. If you have your stereo system plugged into the audio input, when it's adjusting, it's going to have a few false triggers. So I'm standing away from it, I'm out of view. I'm going to stand up, put my hands up, there we go. It's picked me up. I'll stand perfectly still, and I'll move again. And I will move again. And I will move again. So again, you can fiddle around with the variable resistors on the back of the PIR sensor. I'll move again. And now I'm just going to move over to the area I'm going to power it off, because it's going to get annoying with that LED continuously detecting me. So once we've adjusted it, we've calibrated it, I suggest the settings of the variable resistors that I used. Again, if you want to solder to the bottom of the board, oops, out of focus, I apologize for that. Plus 9 volts here, DC ground here. So you can solder a 9-volt connector there. And that provides electricity through the regulator to the rest of the circuitry. So let's power it up again. I'll give it a few seconds. I'll connect it to my computer speakers. This is just a set of computer speakers. You can use your Bose player, whatever you like. The stereo connector that is included in many of the reward tiers plugs from the output jack of the Hallowe'ener into the audio input. You can't plug it directly into speakers because the Hallowe'ener can't provide enough power to drive speakers directly. It needs to have its own amplifier. So something like this that's active, that has its own amplifier inside, can amplify the audio to speakers. So Bose player, boombox, if they still exist, computer speakers, whatever you'd like. I wouldn't suggest having your speakers on full volume when you plug this in. So I'm standing right in front of it. So I'm going to turn speakers up. And I'm walking away so I don't continuously set it off. Okay, I'm going to walk closer. So I haven't added all of the audio bytes for this just yet. I'll be making another video showing off all 10 of the audio bytes I'll be using. I'm going to walk one more time in front of the sensor. And I'm going to turn my, I turned off my computer speakers because it gets really annoying and unnerving. So that's it. That is the assembly and calibration video. I hope if you've pledged towards the Hallowe'ener, sorry, I'm continually setting off the PIR sensor right now from standing in front of it. That's the Hallowe'ener. We've put it together. We've tested it. We've talked about troubleshooting. If you have any questions, check us out at the Kickstarter campaign link below. Ask a question, make a comment. Thanks for your time, everybody.